Good day. Let's do the inverse of exponential equations. So here are two exponential equations that we're going to find the inverse. All right, working on this first one here, you see we have this y equals all this stuff with x as the exponent here. So the first thing you want to do when finding the inverse is you want to swap out the x and y. Okay, so here we have the y, here we have the x. We're just going to simply swap those out. So we could write it like this. We're going to say x equals, 1/4 being raised to the y power minus 5 over negative 2, and all that being raised to the 1/3 power. Okay, this is step number one. Just simply swap out the x and the y. All right, and then the next step is you just want to simply solve for y. So here's y. So we're going to try and get rid of all this stuff and have just y by itself on one side. So you can see that all this is being raised to this 1/3 power. And I think you're aware that if you have x, let's say, being raised to the 1/3 power, that's the same as having the cube root of x. Okay, when you see this fractional exponent, that's the same as having the cube root of x. So what we're going to do to get rid of this cube root of x is just we're going to cube it, right? If you have the cube root of some number and you cube that, okay, the cube root and the cube kind of cancel out, and what you're left with is x. Okay, also note that in your algebra, that if I have some number, let's say x, and this is being raised to, let's say, the a power, and then that's being raised to the b, that equals x to the a times b. Okay, so what that means is for our problem here, where you have this 1/3 being raised to the 3rd power, is that basically it would be like x raised to the 1/3 power times 3, right? 3 over 1. And that cancels out, just leaves the x. So in other words, when you have this fractional exponent being raised to 1/3 and I cube that, okay, that kind of cancels each other out, leaving just the x. So we're going to kind of use that. We're going to use that here. Okay, we're going to take all this and raise it to the 3rd power. Okay, what that does is it cancels out. Oh, remember, whatever you do to one side, okay, you have to do to the other side. Okay, if I'm going to cube all this, I have to cube whatever's on the other side of the equation as well. So here these are going to cancel out. So what we're left with, we have x cubed equals 1/4 raised to the y power minus 5 divided by negative 2. Okay, this is what we have now. So I'm going to go ahead and erase this. Okay, just make sure that you understand how this cancels each other out. Erasing all of this here. And this is what we have. This x cubed equals all of this. All right, now just simply solving for y. First thing we're going to do is multiply both sides by negative 2. So we now have this equals negative 2x cubed equals 1/4 raised to the y power minus 5. Okay, now we're going to add 5 to both sides. Okay, here we have this plus 5. We're going to add 5 to both sides. What that does is cancels it out over here. So now we have negative 2x cubed plus 5 equals 1/4 raised to the y power. All right, now we just need to get this y. We need to bring it down. I'm going to go ahead and erase some of this stuff, some of this work that we just did. And to do that, okay, to get this y to kind of bring it down, that we're going to use this idea that if you have the log of base b of b to the n, that equals n. Okay, so your logarithms, if you have base log b of b raised to the n, that equals n. Okay, so we're going to use this idea. I would write this down. This is kind of important. A little side note. Okay, a little side note of that. So how that's going to work over here is we're going to take the log base 1/4 of both sides. So we have log base 1/4 of negative 2x cubed plus 5. And we're going to say that that equals log base 1/4 of 1/4 to the y. Okay, so once again, we have kind of this idea here, log base b to the n equals n. Okay, so this log base 1/4 and this 1/4 are going to cancel out, and what you're left with is y. All right. So now we have this. We have log base 1/4 of negative 2x cubed plus 5. We're going to say that equals y. And that's our answer. So here we have our answer. Okay, this is the inverse. We just inverted. Okay, this problem, we find the inverse. This is what we get, log base 1/4. Okay, I could probably scoot that 1/4 down a little bit, just so you know that's log base 1/4. Negative 2x cubed plus 5 equals y. Okay, this is the answer, the inverse of this problem here. All right, next problem here, we have y equals 5 raised to the x minus 9 over negative 3, all that being raised to the half power. Once again, we're finding the inverse. The first thing you want to do is you want to swap out x and y. Okay, swap out x and y. So we're going to write it like this. X equals 5 raised to the y power minus 9 over negative 3, and all that raised to the half power. Okay, simply just taking y and x and swapping them out. Okay, step number 1. All right, step number 2, we just want to solve for y. So here's y. We're going to get y by itself. And once again, you see here we have this fractional exponent. Okay, when you have something that's to the 1/2 power, that's kind of taking the square root. Okay, so to get rid of a fractional exponent, once again, we're just going to raise this to the 2nd power. Okay, and what that does is it cancels out here. And what you do to one side, you do to the other. So we need to add this 2nd power here to the x. So now we have x squared equals 5 raised to the y minus 9 over negative 3. All right, erasing some of this work here. So now we need to solve for y. Okay, solve for y. So what we could do is you could take down the bracket, kind of these parentheses at this point. Okay, solving for y, let's multiply both sides by negative 3. So we have negative 3x squared equals 5 raised to the y minus 9. Okay, now adding 9 to both sides, we have negative 3x squared plus 9 equals 5 raised to the y power. Okay, now once again, we're going to use this logarithm rule that we have here. Okay, log base b of b raised to the n equals n. So to do that, we see here that our base is 5, and our exponent is y, so we need to take the log base 5 of both sides. So we have log base 5 of negative 3x squared plus 9. We're saying that that equals log base 5 of 5 raised to the y power. Okay, now this log base 5 of 5 raised to the y power. Once again, here's kind of our key. Okay, you could see that that's just going to equal y. Okay, so we have log base 5 of 5 raised to the y power. That's just going to equal y. So what it does is it kind of cancels out. Okay, so our answer, what we have here, we have log base 5 negative 3x squared plus 9 equals y. Okay, and here's our answer. Log base 5 of negative 3x squared plus 9 equals y. That's the inverse. Okay, we took the inverse, and this is what we get for our answer. All right, here's our next problem. Y equals 4 raised to the x minus 3 over 4, all that being raised to the 1/4 power. Once again, first step when doing inverse is you want to swap out x and y. Okay, let's swap out x and y. So now we have x equals 4 raised to the y power minus 3 over 4, and all that being raised to the 1/4 power. Okay, once again, if you see this fractional exponent, okay, a fractional exponent, you know that if you have x raised to the 1/4 power, that equals the 4th root of x. Okay, a fractional exponent means the 4th root, so 1/4 equals the 4th root of x. And to get rid of the 4th root, you're just going to raise it to the 4th power. Okay, those cancel out. So if you have this x raised to the negative 1/4, you're going to raise that to the 4th power. Again, the reason why that works is because you have x to the a raised to the b. That equals x raised to the a times b. Okay, if you have something being raised to an exponent and then all that's being raised to another exponent, that you multiply those together. Okay, so when you have this x raised to the 1/4 raised to the 4th, that's going to equal x raised to the 1/4 times 4. As you know, 4 could be represented as 4 over 1, which means those cancel out, just leaving x by itself. Okay, so to get rid of this 1/4 power, what we're going to do, move this down a little bit, what we're going to do is we're going to take all of this and raise it to the 4th power. Okay, and what you do to one side, you have to do to the other. So now the x has this 4th power there. Okay, this cancels out. That cancels out. So now we have this. We have x raised to the 4th power equals 4 raised to the y power minus 3 over 4. Okay, this is what we have here. Okay, simply going to erase some of this work. Okay, now what we're going to do here, let me move this up here. Now what we want to do is we want to multiply 4 to both sides. Okay, that gets it across the equal sign there, right? If I multiply this side by 4 over 1, I multiply this side by 4 over 1. Those cancel out, so now I have 4 times x raised to the 4th power, okay, equals 4 raised to the y power minus 3. All right, now I'm going to add 3 to both sides, add 3 here, add 3 here. What it does, cancels out on this side. So now we have 4x to the 4th power plus 3 equals 4 raised to the y power. Okay, that's the point where we're at. And once again, we're going to kind of use this rule here, this logarithm rule, that you have log base b of b raised to the nth power, that equals n. Okay, we're going to say 4 is our base, 4 raised to some power. So what we want to do is we want to take the log of base 4 both sides. So we have log base 4 of 4x to the 4th plus 3 equals log base 4 of 4 raised to the y power. Okay, what that does is this log base 4 and this 4 cancel each other out. So what we have here, we have log base 4. Okay, log base 4 of 4x to the 4th plus 3. I'm going to say that equals y. And here's our answer. Okay, last problem here, we have y equals e to the x minus 10 over 4, all being raised to the 1/5 power. Okay, once again, first thing you want to do when you're inverting is swap out x and y. So what we now have is we have x equals e raised to the y power minus 10 over 4. All that's being raised to the 1/5 power. All right, now what we want to do, once again, is solve for y. So here's y. First thing we're going to do is we're going to raise everything on both sides to the 5th power. Okay, that's going to cancel this out here. So we have x being raised to the 5th power equals e raised to the y minus 10 over 4. All right. So now let's multiply both sides by 4. Okay, multiply by 4, multiply by 4. So now we have 4x to the 5th equals e raised to the y minus 10. By the way, this 4 and this 4 kind of cancel out. So now we're going to add 10 to both sides. Plus 10 here, add 10 here. Okay, cancels out on this side. So we have 4x to the 5th plus 10 equals e raised to the y power. Okay, this is the point that we're at. Now, notice that we have an exponential, but we have base e. Okay, base e. So as you know, natural log and base e are kind of the opposite. So if you have something, if you're going to take the natural log, so ln, okay, remember ln is always going to be base e of e to the y, that's going to equal y. Okay, if you have natural log. So what we want to do is we want to take the natural log of both sides. It's real similar to this idea here, except for instead of some number as a base, we're using the number e as a base. Okay, in e you have natural log, kind of cancels out this e. So we're going to take the ln of both sides. So now we have natural log 4x to the 5th plus 10 equals a natural log of e raised to the y. All right, and what that does is natural log and this e kind of cancel out, leaving us with just the y. So we kind of erase that, and it leaves just the y on that side. So here's our answer. When we take the inverse of this problem here, we get natural log of 4x raised to the 5th power plus 10. Okay, that's your answer. All right, I want to thank you for making it to the end of this video. If you like these type of videos, please hit the like button, leave a comment down below, and subscribe to my channel for more videos. Thank you.